Yeah. So I discussed mechanical pulping, thermomechanical pulping and chemical thermomechanical pulping. Last one is only chemical pulping process. That means there is no refining that or grinding will takes place in this process. So purely individualization of uh, fibers from wood chips with help of chemicals. So so if you see here I explain in the plant cell walls. So this is the lignin. This is the lignin. These are the cellulose crystalline amorphous fibers. Cellulose amorphous crystalline. These are the cellulose fibers, and that is the lignin. And we have the hemicellulose binding to this. Hemicellulose binding to this. So in the chemical pulping process, basically we wanted these cellulose fibers to be isolated. We wanted these cellulose fibers to be isolated, and we wanted to separate this lignin. That is the best way to separate. So in this chemical pulping process, basically all this is happened by the intermolecular binding between these materials. In a reality, how these are holding together because of there is some intermolecular binding between cellulose, hemicellulose, lignin, hemicellulose that is happening. So in the chemical pulping process, they wanted to attack this intermolecular bonds between lignin, hemicellulose and cellulose so that you will be able to separate this cellulose and hemicellulose and lignin into separately. So there are two methods. One is called Kraft pulping process, that is also known as sulfate pulping process. Another one is sulfite pulping process. Another one is sulfite pulping process. In the sulfate process, which is also known as Kraft pulping process, they use sodium sulfide Na2S and sodium hydroxide. They will use these two chemicals. What these two chemicals basically does, that will attack the intermolecular bonds between lignin, hemicellulose and cellulose. That way they will separate them into individual components. So when you mix wood chips in the presence of the sodium sulfide and sodium hydroxide, if you leave it for a certain time for the reaction to happen, these molecules go and reacts and breaks these intermolecular bonds and separate them into cellulose and hemicellulose and lignin. You can separate them into individual components. So the advantage with Kraft in case of sulfide process also, sulfurous acid and bisulfite ions both are added, and these also breaks the intermolecular bonds between lignin, hemicellulose, cellulose. Then they will separate into cellulose fibers and lignin. Now lignin, another thing with lignin is a flaky material, flake-like material. Lignin is a flake-like material. If you see lignin, you will see flakes like this. It will like a flakes-like material. Whereas cellulose is a fibrous material. Hemicellulose like a fibrous but mostly soft gel-like material. So in the pulping process, if you have this flaky-like material, this is always obstructive because these are not flexible. Hard material. So that's why the presence of lignin creates not only darkness, it also hinders the pulping paper making process. That's why they wanted to separate. So when you add this sodium sulfide or sodium hydroxide in case of Kraft pulping process, or sulfurous acid in case of sulfiding process, what will then be separate this flake material and fibrous material. After the breaking of intermolecular bonds, you can separate this flaky material and this fibrous material, and this fibrous material can be taken and used as a pulp. So in the modern, although sulfide pulping can be used, but in the current paper mills at this stage, every industry is using kraft pulping process only. The reason is recovery of chemicals and energy can be achieved 95%. The recovery of chemicals and energy can be achieved 95%. That means what? You don't need every time, you need to add only 5% of additional chemicals, and you need only 5% of additional energy. So self-sustained, a self-contained pulping process. So that's why most of the paper mills use kraft pulping process only. Very rare. There, I'm sure, as I heard, there are no unit sulfide pulping used based on the sulfide pulping process. So what happens in a kraft pulping process? The wood chips, the wood chips, the wood chips put in a digester. This is simply like a autoclave reactor. The digester is like a autoclave reactor. Autoclave reactor looks like a pressure cooker only. Looks like a pressure cooker only. So they add chips, then they add these chemicals, these two chemicals, Na2S and NaOH. They will add Na2S and NaOH. NaOH. They will add these chemicals. So they will add these chips and they will close the lid. It is autoclave reactor is basically as I said, it's like a pressure cooker only. So the whole thing is closed, tight, closed and very tight. As you heat it, the steam will generate. The steam will generate. That steam will create lot of pressure is inside. The steam will create lot of pressure inside. So usually autoclave reactors are high pressure reactors. Autoclave reactors are high pressure reactor. So what we are doing is, even in paper mill they call cooking. They take wood chips, they cook in presence of these kraft chemicals, that is Na2S and NaOH. After you digest for sufficient amount of time, almost like 3 to 6 hours, 3 to 6 hours is very long time, 3 to 6 hours, very long time, then what you will get is in the after cooking for after digesting for 3 to 6 hours, it will have three things. You will have three things. You will have a flaky materials, all the dark brown color flaky materials is settled at the bottom. Then you have a fibrous material floating at the top, the fibrous material floating at the top. Then we have non-condensables and extractives. Like I said, right, if you have eucalyptus tree, you will have extractive. One of the predominant extractive is eucalyptus oil. So those sort of oils and non-condensable floats on the top. Those sort of oils and floats on the top. So this is a thick suspension. This is thick suspension. This is only a clear liquid. This is only a clear liquid. So the clear liquid is separated. And these extractives are used and they purify it and they sell it. And the bottom one, the thick suspension sent to a blow tank. What is blow tank? Blow tank is like an empty chamber. The blow tank is like a empty chamber. Here, in the digester, this is pressurized, right? So it will have a steam and it will have a steam water. Well, water will be there. So and we also have the thick suspension. Once you send this blow tank, like if you have any the hot concentrated suspension, if you send the blow tank, what will happen is suddenly you are exposing to a lot of free area. So that means here is high pressure, and if you introduce into blow tank, it will be at low pressure, this atmospheric pressure, and whatever vaporizing components are there, easily vaporized components are there, they will come out as vapors, and whatever concentrated suspension will be come down. So the blow tanks are empty tanks where you are simply introducing this high pressure liquid, so that you are reducing the pressure. When you reduce the pressure, what will happen? If any volatile components are there, they will vaporize and goes upward, comes outside, and whatever concentrated thick suspension, they will just fall down. They just comes to the bottom. Blow tank is just blowing it, sending the high pressure stream into a blow tank to reduce the pressure. To reduce the pressure. So here, little bit need to be focused because I kept a big flow sheet here. So please try to pay attention. Wood chips sent to a digester and chemicals, recovered chemicals back from here, NaOH and NaOH, right? And after digesting from 3 to 6 hours, the liquids sent were non-condensables and extractives like turpentine, those things will come out, and whatever the concentrated suspensions are sent to this blow tank. From this blow tank, what you get is steam, high pressure steam will come and go to this heat exchanger section, and this concentrated suspension come from the bottom. As I said, two layers will be there in the digester. One is fibrous material. It has in the digester has three layers, right? Liquid, that is non-condensables and oils. Then we have the fibrous material. Then we have the flaky brown color liquid. So this brown color liquid contain lignin. This fibrous material contain cellulose. Since we are heating at high temperature, the hemicellulose gets dissolved. Hemicellulose gets dissolved in water at high temperature. So it will become like a simple solution. It will forms like a simple liquid solution. Here we have the pulp filter. This pulp filter, what it does, it separates this fibrous pulp. And the brown color liquid. That brown color liquid will be called as black liquor. This black liquor contains 13% solids, that is 13% lignin, and remaining all liquid. What are the liquid? What is the liquid? As I said, right, these intermolecular bonds are break down. How would break down? They get dissolved. So it will form some other chemicals. So here, this is the, we already got a pulp here. Required pulp here. But now the rest of the process is energy recovery and chemicals recovery process. So, energy recovery and chemicals recovery process here. So this is the very, very important part of the industry, because industry want to minimize the net energy demand. Or net chemical demand. That's why the pulping is very simple, but recovery of chemicals, recovery of energy is the complicated, and that's what they are doing here. So I'm not explaining all the chemistry. In case if you want to interest in chemistry, this you can go through this link. All the reaction chemistry is given. Just in the interest of time, I'm not going to that detailed chemistry. What are the reactions happening? How they are recovering, and all those things. So first one is oxidation tower. So any combustible materials are there. because this is this is contain carbon hydrogen oxygen, so definitely certain amount of hydrocarbons will form. So first it will be sent to the oxidation tower. In this oxidation tower, whatever combustible components are there, they will be oxidized, and it releases some heat. It will release some heat. It will release some heat. That hot liquid will be sent to this evaporator. You might know the evaporation process. Evaporation contains two things. Any evaporation process contains two stages. One is heating, then then any evaporator has two zones. One is heating zone, another one is reduced pressure zone. Reduced pressure zone. Why we use heating? So that it can volatile components or vaporizable components will reach the required temperature. When you reduce the pressure, whatever hot components are there which can form vapors, they will immediately vaporize and goes up. For example, let's say we have cellulose or lignin material and we have water, and we wanted to remove this water. From this. If I simply heat it, what will happen? This will get burnt. The material can get burnt because this is a soft material. So we won't heat it for a long time. Rather, we heat it up to 80 degrees centigrade, lower than the boiling point temperature of water. We will heat up to 80 degrees centigrade. Then we will send to a vacuum chamber. So when you send vacuum chamber, because we know we will adjust the vacuum such that the water can vaporize at 80 degrees centigrade. That way, every evaporator has heating zone and reduced pressure zone. So in this oxidation tower, heating is done, then sent to this evaporator so that you can remove steam, contaminated water, and these type of sulfur component, because wood also have the sulfur. So H2S and CH3S mercaptans also removed from here. Then after evaporation, since we removed the steam and other thing, you will have the concentrated black liquor. So 50% of solids will be there. Again, it will send to the another evaporation process. It will make it 70%. Solids. So 70% solids. Upon adding Na2SO4, from this whatever liquid, this Na2SO4 reacts with the chemicals which is formed there and converts to Na2S and NO2CO3. This reaction chemistry, which you can refer to that link, because I don't want to explain those reaction chemistry again. So that way you will be able to get NADS back. Upon adding Na2SO4, small amount of Na2SO4, you will get NADS and Na2CO3. Then you have the lignin. They burn this lignin. So when you burn this lignin, it gives lot of heat. That heat will be whatever heat produced here in the furnace. That energy will be utilized for digester and other processes. That way, by burning the lignin present in the black liquor, whatever heat liberated, that heat will be utilized for the energy for the remaining operations. So the NADS is formed, and again you will get the NaOH is also formed here. So the NATS and the NATS which is formed here will sent back to the digester. So that way, the recovery of chemicals and recovery of the energy they do in this craft pulping process. I hope you are able to understand. If you have any questions, if you could not understand when I am explaining, please ask me. If any student could not understand any step in this flow sheet, please ask me. Okay. So here I just put again, because since that flow sheet is a lot of steps, I explain, put in terms of words in a simple way. So cooking mixture, that is NaOH and sodium sulfide NaOTs and wood chips sent to the digester. Digester is typically a stainless steel vessel. Digester is a typically stainless steel vessel, looks like a pressure cooker. In this digestion process, the temperature is raised up to 170 degrees centigrade and maintained for 3 to 6 hours. Maintained for, I think I wrote 4, but 3 to 6 hours. Upon digesting for required amount of time, the clear liquid from the digester, which contains non-condensables and extractives, are separated. Black liquor and fibrous pulp introduced into blow down tank. Blow down tank, since digester is maintained at high pressure, this high pressure liquid is sent to a blow down tank to remove the some amount of steam present in it. So after the blow down tank, pulp, uncooked wood means unconverted wood, and black liquor, dissolved organic matter and chemicals are separated. Dissolved organic matter and chemicals are separated. After that, this pulp and uncooked wood is separated using the screens, and black liquor concentrated using the evaporation process. This lignin and organic matter is sent to oxidation chamber, combustion chamber, where this the burning of lignin and organic matter will take place. During that burning or combustion process, lot of heat will generate. That heat will be utilized as an energy recovery. That energy produced in this process will be utilized in other process like digester and other thing. This unburnt inorganic matter mixed with NaOH and forms Na2S and Na2CO3, then mixed with calcium hydroxide. So when you react sodium carbonate and calcium hydroxide, that will form NaOH and CaCO3. That way you get Na2S and NaOH back, and this will be sent back to the digester as a chemical recovery. So this way we can produce chemical pulp. So chemical pulping process, although the pulp contains only cellulose, but during the reaction some amount of lignin particles tend to mix, and also this organic components present in that one also makes it slightly dark yellowish color or slightly light brown color. So since pulp is not in bright in color, the chemical pulping process or the pulp from the chemical pulping process always followed by a bleaching process. In this bleaching process, they will add various of bleaching agents. Bleaching agents like chlorine, sodium hydroxide, chlorine dioxide, sodium hypochlorite, oxygen, hydrogen peroxide, ozone. So these are the different concentrations. I have also listed the concentrations, and these all bleaching mixture will be mixed to this chemical pulp. Upon mixing these bleaching agents with the chemical pulp become a very bright, almost like a white in color, and see, it will be like this. will be like this. This is the chemical pulp after brightening. This is the chemical pulp after brightening. You will get very wide type of pulp you will get. So chemical pulp, the pulp produced from the chemical pulping process used for the writing paper and printing paper. Writing paper and the printing paper. So whatever white paper we see for the books writing we use, that is predominantly made from the chemical pulping process. Predominantly made from the chemical pulping process. Even the printing papers, and that is also made from the chemical pulping process. So even the tissues, toilet tissues or hand like wiping the hands and all those tissue papers, that is also made from the chemical pulping process. So in the abroad, like foreign markets, predominantly tissue paper. So the most of the industries in the foreign countries will be chemical pulping process only, because currently the market is only tissue paper there, because they use extensively tissue paper for various needs. So here I just combined it, all type of pulping processes. So this is the mechanical pulping process. Wood undergoes refining or grinding, then screening, then thickening, then bleaching and storage. That I already explained. Now here, this is chemical pulping process, right? So we have chipper. So the wood converted to small chips that will be sent to digester. In the digester, chips and the cooking liquor based on the craft pulping or sulfide process, they will add NaTs and NaOH, then digest for certain amount of time, then blow down tank, then screening, then bleaching. So that we will get the chemical pulp. We can also get pulp from the waste paper, recycle, like your paper or any boards or any sort of waste thing, waste paper or waste boxes, all the thing can also be made as a pulp. That is recycling. So the waste paper, that's why nowadays government is taking initiative that don't mix dry waste and wet waste. If you have the dry waste, which is dominantly paper waste, right? So that can be recycled back. So it'll have a pulper, because this is only paper, but it'll have ink and other inorganic materials. I will explain in the later slides. Inorganic materials, ink and other inorganic materials. So basically we need inorganic materials and we also need pulp. Only thing is that they have to separate this ink. White paper, waste paper, we print, right? We will write sometimes and we print sometimes. So often it will contain this ink. So in this pulper, what it does is like a small CSTR reactor. It's like a typical CSTR reactor. They will take this waste paper and cuts into small pieces and they'll throw it here. Then they will add hot water or steam, and then it will become very soft. Very soft. Now this ink, right? Ink is sticking to pulp, so they will add surfactants. The surfactants reduces the interfacial tension between the fibers and the ink. The surfactant reduces the interfacial tension between the fibers and the ink. That way, after adding the surfactants, all the ink will be floating at the top. Like a foam. Just foam is floating like that. All the ink will be floated. So they will scrap out that. Then they will send this pulp. So they will separate converted pulp and unconverted paper. Then again send back to the pulper. That way, you will get this recycled pulp. You will get the recycled pulp. So, so, so we can make pulp three ways, right? From mechanical pulp or chemical pulp or recycled pulp. So usually recycled pulp, the fibers made from the recycled pulp very weak, doesn't have much strength because that is the reused. The mechanical pulp is strongest, stronger than chemical pulp. Mechanical pulp is stronger than the chemical pulp. So often the recycled pulp will be certain percentage, 10 to 20 percentage, 20% will be mixed with the 80% of pulp from the chemical or mechanical pulp. They mix it so that way you will be able to utilize the recycled pulp very well. That way you will be able to utilize the recycled pulp. So they will never make paper from only recycled pulp because it is a weak fibers. So they will mix with chemical or mechanical pulp and they will make it. So so this pulp made from, let's say, chemical pulping or mechanical pulping after bleaching, they will, although it is bright in color, but before making paper into pulp, they will add certain inorganic components, also called as fillers. I will explain why they are adding these fillers after few minutes. Why they are adding these fillers? So these fillers are often inorganic components. These fillers are often called inorganic components. So typically they add clay or calcium carbonate. They will add typically clay and calcium carbonate fillers are added. Now see, this calcium carbonate and clay are inert particles. These are the inert particles. Now if you take pulp, this is cellulose chain, so it will have OH, and sometimes it will have COOH. So carboxylic groups it will have COOH, and carboxyl groups it will have. So if you mix these fibers and these fillers, fillers particles, they will never bind together. If you don't bind these, what will happen once you stop mixing? What will happen? They will settle. These particles will settle, and the fibers floats. So, but we wanted these particles. They wanted particles to be in between with the fibers. They wanted the particles to bind with the particles. So to bind these particles with fibers, they will add some cationic water soluble polymers. Water soluble polymers. Why they add cationic water soluble polymers? This is the carboxyl groups. This carboxyl group makes them anionic. This carboxyl groups makes these pulp fibers makes them anionic. So these polymers, these water soluble polymers, can bind with these particles, can also bind with these fibers. So what will happen? This polymer binds these fillers with these polymers binds these particles with this fibers based on the surface charge. So that's what you see here. They add sizing agents. They add dyeing agents. Suppose if you want to make a brown color paper or pink color paper, you need to add dye. But if you want only white color, you don't need to add dye. So they'll add clay and calcium carbonate. These are the fillers, and we'll add the sizing agents like polymers and other sizing agents. I will tell you why these sizing agents one more time. Okay, maybe better to explain. So sometimes you will see different papers like shining papers, and sometimes it's just white papers. White paper. Sometimes you will have the shining papers, like not completely photo papers, but sometimes you will see light shine papers, right? So how you get this shining or brightness? How you get that photo paper will have very strong bright? So they will add what is that called? I just could not remember. We have very a well-known chemical, very, what is that? Could not remember. I will just tell you that one. So what? Very simple name. Uh, I'm only remembering Telugu name, but not remembering English name. Never mind. I will probably I hope I'll remember by end of today's class, and I will explain. So they will add this material as a sizing agent. So what will happen is, when you add that material, upon heating, that forms a thin shiny layer. It will form a thin shiny layer. So depends upon the needs, right? Depends upon the need, they will add sizing agents, clay or dye. But as soon as they add clay and other fillers, definitely they will add one sizing agent, that is polymer. What soluble polymer, they will add it. So here, here, so after adding this fillers, like pulp, this is pulp, and fillers, inorganic fillers like clay particles or calcium particles. Then we have the sizing agents like cationic water soluble polymers and other based on the depends on required. All these are sent to a mixing chamber. They call it as head box. In paper mill they call as a head box. In head box, what will happen is this pulp, wet pulp, and fillers and sizing are mixed together. Here they won't use any mechanical stirrer, like they don't use this. Rather, by maintaining this high velocity stream, by maintaining this high velocity pulp stream, if you create turbulence, by maintaining high velocity pulp velocity, this whole thing gets mixed. The whole thing gets mixed. So this is called head box. So this head box, outlet from the head box will contain a suspension that contains fibers, fillers, and sizing agents and water. So this whole suspension, this whole dilute, and also they will add a lot of water, because this is concentrated pulp. This is concentrated pulp, and they will dilute. They will also add water. So water is introduced at high velocity to create turbulence for the uniform mixing. So that way you will get the very dilute, almost 1%. The pulp will be only 1% by weight, This dilute liquid suspension, which contain fibers, is sent to a screening. This is a screen. It's like a mesh. So this is like a screen. Like a mesh. So this is very fine mesh. Very fine mesh. Often this is 150 mesh size. 150 mesh size they will use. So once you pour this, this is continuously rotating. This pulp suspension from head box is poured onto this one. The pulp suspension head box is poured onto this one. Now this size of the screen is smaller than the fiber size. The size of the screen is smaller than the fiber size. So what will happen when you pour this? On the screen, water will fall down. The water passes through this. And these fibers, the fibers with fillers retained on this. is retained on this. The fibers with fill are retained on this one. So as the screen moves, they will apply vacuum. They will apply vacuum. They will apply vacuum. So by the time it comes to this point, let's say when the screen travels from this point, by the time it reaches here, you will get a wet film. You will get a wet film with certain mechanical strength. You will get a wet film with some mechanical strength. And here this screen is rotated back. This screen is rotated back with help of certain certain gears. So once the screen is rotated, they will separate this wet film. They will separate this wet film. They peel it off. So you will get weak wet film. You will get a weak wet film because this is hydrophilic, and the cellulose in the presence of water becomes very weak. So immediately you need to dry it. Then only it will become mechanically strong. So how do you dry it? They will take the steam hotted rolls. Like you have a mechanical rolls. Inside it will have steam. Inside it will have a steam. So steam heated rolls. They call steam heated rolls. So they will rotate in opposite directions. So there will be small spacing. So this wet film is passed through the steam hotted rolls. So that it will be, two things will happen. One is drying will happen, and also uniform thickness also will be maintained. So that's what you see here. You can see here the screens and head box and press wire where screening is happening. Then we have the drying. In the drying process, the wet film is dried and it will get stronger and stronger. As it dries, it will become stronger and stronger. Then they will add size press. Although they are doing drying, in the previous case they just dry out the roll. Now they wanted to make the uniform thickness. So they will spray little liquid, then they will pass through a specific thickness. The spacing between the roll will be specific, so that they will get a uniform thickness roll. So that way they will do the size press to maintain the uniform thickness. Again they will dry it. So depends upon requirements of the paper. If you want a glossy paper, shiny paper, normal paper, they will do the coating process. Or if you want to print it, if you want to make a different color, they will coating process. And after that, they will do the reeling. You will see big bundles. of the paper. They get it. Big bundles of the paper. They get it. Then of course, reel packing, sheet cutter, packaging. These are all the normal process. The big bundles will be cut into small spaces, and they will supply it. So this is the overview, or I have given good amount of details of pulp and paper process. I hope you have understood. So that's all for today's class. If you have any questions, please let me know. I hope you understood. Students, have you understood certain things about pulp and paper? Okay. Yes. Yeah, thank you. Okay, thank you guys. If you have any questions, you may ask me now. Otherwise, you may leave and join the next class. Okay, probably no questions. Thank you. Have a great day. And we'll meet. Okay, forgot to tell why I did not take Monday's class. Actually, I had a gate examination work in the last week, Saturday and Sunday. So I went to some other place from Kharagpur. They booked train such that I will reach at 9 o'clock, but train was running late for 2 hours. So that's why I thought I will reach by 9 and I will take class at 10, but train got delayed for 2 hours. So I had to cancel the class, and I sent that email last Monday. And sorry for that inconvenience. And thank you once again.